Hello students, my name is Sanket and I welcome you back to my world of mathematics in Sanket Sir's Maths Academy. Let us continue with the topic of trigonometry. In this video, we are going to discuss the relationships between the different trigonometric ratios, and we will also learn about the trigonometric ratios of complementary angles. In the last video, we have learned about the six trigonometric ratios: sine, cos, tan, cosec, sec, cot. And what were the definitions of these six trigonometric ratios? Sine theta was opposite side upon hypotenuse, cos was adjacent side upon hypotenuse, tan theta was opposite side upon adjacent side, cosec, which was reciprocal of sine, that is hypotenuse upon opposite, sec, which was reciprocal of cos, that is hypotenuse upon adjacent, and cot, which was reciprocal of tan, that is adjacent upon opposite side. Now, these ratios are defined for acute angles in a right angle triangle. Here we have a right angle triangle ABC, right angled at B, and A and C will be the acute angles. We consider angle C as theta, and for theta, what's the opposite side? AB. What's the adjacent side? BC, and AC we know is the hypotenuse for this right angle triangle. So let us quickly define the six trigonometric ratios for this angle theta in triangle ABC. We have sine theta AB upon AC, that's opposite upon hypotenuse, cos theta BC upon AC, that's adjacent upon hypotenuse, tan theta AB upon BC, that's opposite upon adjacent, cosec theta reciprocal of sine, that is AC upon AB, sec theta reciprocal of cos, that is AC upon BC, and cot theta reciprocal of tan, that's BC upon AB. Let us now understand the relationships between the different trigonometric ratios. So, the trigonometric relations. We know that cosec theta is reciprocal of sine theta. What was the connection here? We had learned that if we look at the third letter of cosec, that is S, from the original three trigonometric ratios, what starts with S? Sine. So we had said that cosec theta is reciprocal of sine theta. Now students, sine theta can be written as sine theta upon 1. So what will be reciprocal of sine theta upon 1? It's going to be 1 upon sine theta. So cosec theta can be written as 1 upon sine theta. Now, if I try to shift sine theta from right side to left side, that is, it goes from denominator to left side numerator. And cosec theta from left side numerator, if I take on right, cosec theta will come as denominator in the right side. I can write now as sine theta goes to the left, that is sine theta, and cosec theta comes in the denominator of right, that is 1 upon cosec theta. So I got other way of writing the first relation, that is sine theta is equal to 1 upon cosec theta. Again, cosec theta can go and multiply on the left side with sine theta. That means I will be getting sine theta multiplied by cosec theta, and that will be equal to what remains on the right side? 1. These are the three different ways of writing the first trigonometric relation. Cosec theta is 1 upon sine theta, or sine theta is 1 upon cosec theta, or sine theta multiplied by cosec theta is 1. The next trigonometric relation is about sec theta. Now we know sec theta is reciprocal of cos theta. Same thing to remember, third letter of sec is C. From the original three trigonometric ratios, cos starts with C. So sec theta is reciprocal of cos theta. Cos theta can be written as cos theta upon 1. That's how we write all the integers. If 5 can be written as 5 upon 1, cos theta is cos theta upon 1. Its reciprocal is going to be 1 upon cos theta. So sec theta is equal to reciprocal 1 upon cos theta. And just like sine theta, if I shift cos on the left side, that's numerator, Sec theta comes on the right side as denominator, so I get other way of writing my second relation, that is cos theta is equal to 1 upon sec theta. Again, sec theta can again go on the left side, gets multiplied with cos. I can write that also as cos theta multiplied by sec theta is equal to 1. Three different ways of writing the second trigonometric relation, that is sec theta is 1 upon cos theta, or cos theta is 1 upon sec theta, or cos theta multiplied by sec theta is equal to 1. And the third trigonometric relation is, we know cot theta is reciprocal of tan theta. Same relation, third letter T, what starts with T is tan. So cot theta reciprocal of tan theta. Tan theta can be written as tan theta upon 1. Its reciprocal is going to be 1 upon tan theta. Cot theta is 1 upon tan theta. Again, interchange. Tan theta take on the left side, cot theta take on the right side. It becomes tan theta is equal to 1 upon cot theta. Correct. Now, again, cot theta can get multiplied to tan theta on the left. I will get another way of writing tan theta multiplied by cot theta, which will be equal to 1. Now, let us go back and look at the definitions of sine theta and cos theta. Sine theta was opposite side upon hypotenuse. Cos theta was adjacent side upon hypotenuse. Now what if I take sine theta divided by cos theta, or sine theta upon cos theta? That will give me opposite side upon hypotenuse divided by, that is whole upon, adjacent side upon hypotenuse. What I see here is I can cancel out the denominator hypotenuse from denominator of the upper fraction and the denominator of the lower fraction. What I get then is opposite side upon adjacent side. Now students, if you observe, what was opposite side upon adjacent side? It was the definition of tan theta. So I can say that opposite side upon adjacent side is equal to tan theta. So what I got is sine theta upon cos theta is equal to tan theta. We get our next trigonometric relation, that is tan theta is equal to sine theta upon cos theta, right? So tan theta is equal to sine theta upon cos theta. Also, cot theta was 1 upon tan theta, that is reciprocal of tan theta. In other way around, when tan was opposite upon adjacent, cot was adjacent upon opposite. So whatever is tan, just take reciprocal upside down, it becomes cot. Now tan is sine upon cos. So what will be cot? It will be cos upon sine. Yes, cot theta is equal to cos theta upon sine theta. That's our last trigonometric. Let us now study the trigonometric ratios of complementary angles. What do you mean by complementary angles? Complementary angles are those angles the sum of whose measures is equal to 90 degree. Now let us consider our triangle. I have taken a triangle here ABC with angle B as 90 degree, right? Then there are two acute angles, angle A and angle C will be the acute angles, from which angle C I have considered as theta. Then we also know in a triangle, the sum of measures of three angles is always equal to 180. So angle A plus angle B plus angle C is 180 degree. Angle sum property of a triangle. But if I write angle A as it is, what is angle B? Angle B is 90 degree. What have we considered as angle C? It is a theta, and the addition of 3 is 180 degree. Now if I transfer 90 degree on the right side, 180 minus 90, I would get 90 degree. And if I transfer positive theta to right side, it would be minus theta. So I get angle A as a 90 degree minus theta, as I have written here in the triangle. Now, let us write down the trigonometric ratios for the angle theta. Now in triangle ABC, for angle theta, AB will be the opposite side, BC will be the adjacent side, and for this triangle AC is the hypotenuse. Now let us write down sine opposite upon hypotenuse, that's AB upon AC, right? AB upon AC. Cos theta adjacent upon hypotenuse, that's BC adjacent upon hypotenuse AC, BC upon AC. And tan theta is opposite upon adjacent, so opposite AB, adjacent BC, AB upon BC. Then the next three trigonometric ratios, cosec, sec, cot, are reciprocals of the first three trigonometric ratios. Cosec, reciprocal of sine, AC upon AB. Sec, reciprocal of cos, AC upon BC. Cot, reciprocal of tan, that is BC upon AB. And the trigonometric ratios of the other acute angle, that is A, that is 90 minus theta, will be sine 90 degree minus theta, opposite side of A upon hypotenuse, that is BC upon AC, cos of 90 degree minus theta, adjacent side AB upon hypotenuse AC, AB upon AC, and tan of 90 degree minus theta is opposite side BC upon adjacent side AB, BC upon AB. Then the remaining three trigonometric ratios, cosec of 90 degree minus theta, reciprocal of sine, AC upon BC. Sec of 90 degree minus theta, reciprocal of cos, AC upon AB. And cot of 90 degree minus theta, which is reciprocal of tan, that is AB upon BC.
Now students, observe the values of trigonometric ratio of theta and those of the trigonometric ratio of 90 minus theta. While sine theta is AB upon AC, cos 90 degree minus theta also AB upon AC. Therefore, I can say sine theta is cos 90 degree minus theta. Likewise, also cos theta BC upon AC. What is sine 90 degree minus theta? BC upon AC. So that will match. We have cos theta is equal to sine 90 degree minus theta. Similarly, we can match the values of the trigonometric ratio of theta versus some other trigonometric ratio of 90 degree minus theta. If you keep matching the values, what you will get is this. You will get cosec theta is equal to sec 90 degree minus theta. Sec theta is equal to cosec 90 degree minus theta. Tan theta is equal to cot 90 degree minus theta. And cot theta is equal to tan 90 degree minus theta. These six formulae are the formulae for trigonometric ratio of complementary angles. What do you mean by complementary angles? The sum of these two acute angles, which is equal to 90 degree, which is why if one is theta, other will be 90 degree minus theta. Trigonometry trivia. So what do we learn today? Today we go back to around 3000 BCE and see how trigonometry started. So this was the time while the pyramids were being built in Egypt. The people involved were trying to study the lengths of sides of the triangles, and to find out one of the side of the triangle, they tried to draw a circle such that the triangle fits something like this, and the required side formed what is called today as the chord of the circle. So basically they were studying about the lengths of the sides of triangles. How many sides does a triangle have? Three sides. So they were studying about length of three sides of triangles. Three sides, trigono, lengths, metron. Yes, they were studying about trigonometry, and that's where the trigonometry as a mathematical concept began. Right? So the trigonometry began somewhere around 3000 BCE. That is 3000 years before our today's AD started, Anno Domini years started. Now cut to from 3000 years before to about 476 to 550 years before. Our own Indian mathematician Aryabhatta. Do you know what is Aryabhatta credited for? He is credited for the discovery or the invention of the number 0. So Aryabhatta, a mathematician astronomer as well as physicist, was the first person to introduce the mathematical concepts, the first two trigonometric ratios of sine and cosine. Thereafter, after 400 years and more 300 years later, the other trigonometric ratios were introduced to us by Persian mathematicians.